My name's Shayon. I'm a partner on the investment team at Multicoin. Spent a lot of time thinking about AI and DePINs, so it's fortunate that we're talking about AI and DePINs. I'm excited to be joined with a bunch of founders at very different layers of the stack, all kind of very involved with AI. So I think we can start off with intros and tell us a little bit about what you're working on and just give us a little bit of background.
I'll just start. Hi, my name is Yannik. I'm a co-founder and CEO at Arcium. And what we're doing at Arcium is building out a decentralized confidential computing network. We call ourselves the first parallelized confidential computing network. So what we're offering is a generalized architecture in which any computation can be performed over any types of encrypted data inside of our network. And what's so new and such a big breakthrough of our architecture is that we are offering the most trustless confidential computing that we've seen so far, with the dishonest majority trust assumption in our network. So you don't need to trust, you can simply perform computations over encrypted state with us.
Hey everybody, Scott Sigel, COO of the Helium Foundation, and we build wireless networks. Helium launched back in 2019. The key focus was how do you create better wireless connectivity for low power, long range sensors. So think in terms of things that are supply chain tracking or air quality sensors, stuff that was really missing and needed better connectivity where centralized networks had kind of failed to provide adequate services or was cost prohibitive to kind of a broader set of people. Fast forward a few years, we took our same model and, with our global community, expanded the network to also create a second product in a mobile network. So building up more cellular connectivity. Over 100 organizations running IoT solutions on the IoT network and on the mobile network. I believe we are nearly 100,000 subscribers to the first crypto native cell phone carrier with Helium Mobile.
Hey everyone, my name is Isaac, CEO of Synesis One. What we are is an enterprise AI data engine. So we provide corporations and government entities with data solutions ranging from data generation to data pre-processing. What data pre-processing is pretty much cleaning and getting data ready for use to train AI. We're seeing a bunch of enterprises trying to use open source models as well as develop their own systems, but they come to realize that they need in-house resources, or they lack the in-house resources to do a lot of the cleanup work for getting their data ready. So that's where we come in and provide the scaling solutions with a token incentivized network.
Hi, everyone. My name is Ryan. I'm an advisor to the Render Foundation. The Render Foundation is the foundation side to the Render Network, which you just heard about from Trevor, one of our board members. I joined the Render Network to help bring the initial network from Ethereum to Solana recently, as of last November. And related to our discussion today, we mostly fall on the compute side of the stack and have a very vast network composed of a lot of different consumer, but also small to medium-sized data centers that have a lot of GPU compute, which is relevant for our AI discussion today.
Awesome. Cool. So we can start kind of double clicking on some of these. I think generally when people think about the constraints to scaling AI, the sort of terms that you think of are compute and bandwidth and data execution environments. I know each of you are working on very specific layers of that stack. So maybe talk a little bit more about what specifically you're doing in terms of aggregating resources and solving a specific layer to that problem. Maybe we'll start with you, Ryan.
Sure. So, as I was kind of just riffing, there's a lot of compute out there in the world, outside of the sort of typical data centers that we see, a lot of gaming and, where we started with the Render Network, a lot of compute required for film and 3D rendering is available. And the tough part of aggregating that compute is having a centralized or decentralized way to aggregate and then pay out individuals that participate in providing different types of compute. And so, of course, we turn to a token and to a decentralized network that allows for a very distributed, decentralized group of computers in houses, small office parks, all around the world to be unified into one sort of aggregated network. And that's really perfect for tokens. And that's really perfect for decentralized blockchains because it solves a lot of the payment issues that are required if you want to do business with somebody that's in Croatia and Tennessee and somebody in Australia. Without tokens and without a way to aggregate all of the supply, we'd have so much overhead that would fall under, a lot of salaries paid on the operational side. And so we found great success with that. The Render Network has hundreds of thousands of GPUs on the waitlist, and we have very happy nodes participating in mostly rendering work today, but we're expanding that into broader types of AI work, from training to inference, and as you'll hear from some of the other folks, some other interesting areas as well.
Yeah, speaking on the data side, so we see, the three pillars of AI right now is data, compute, and algorithms. And there's obviously the constraint on compute as these models get more complex and larger. But there's a huge constraint on the data side going forward. We've seen how many tokens that OpenAI uses for their latest GPT. And a lot of these publicly available scrapable data is pretty much exhausted. So there's going to be a huge demand in new sort of high quality human created data. And this is required to take the algorithms to the next level, the next generation. And so we're going to see a huge demand in and valuation of just these data, mainly in sort of like the reasoning chain type data and subject matter expert domain specific data. And not just data that the humans provide. There's a lot of synthetic data solutions coming out. But even with this, I think there's a lot of human curation needed in order to make the models good. And with a lot of AI generated data that comes out, I think what's going to be important in terms of Web3 is being able to provide the proof of origin of the data. So we need to know what data is human made, what data is synthetic. And, each types of data have their own use cases, but you need to know where it comes from. And especially when it comes to domain specific data, you need to know that whoever's providing that domain specific knowledge is a reputable person within that field. So a lot of this, the whole data field will evolve into sort of this whole proof of provenance or proof of origin plus, high quality reasoning type data to take the models to the next level.
So kind of, I guess, continuing that thread around data and, how that's collected in a kind of connectivity layer almost sits as the, kind of beneath that, if you will, because obviously, you look at these human scale applications or the ability for folks to participate in these incentive networks, connectivity is kind of a crucial element that sits at that base layer, whether you're talking about, you scraping regional specific data or you looking something around foot traffic where, the geography absolutely matters. And this is really the power of where Helium comes in of, telco traditionally has been a top-down model. So, large enterprise telco is really building for where there's, dominant traffic, where they're going to see significant returns. and really where the volume is there for their subscribers. So having the agency and having the ability to deploy your own wireless coverage, whether that is for compute or for you're looking for kind of application specific data, again, like looking at like monitoring foot traffic as a perfect example, like that connectivity layer is what's going to support a lot of these region specific data inputs. And we're certainly seeing like, some of this existing on Helium network, where on the mobile side, obviously just that kind of Wi-Fi connectivity for more high bandwidth applications, but even on our IoT network, which is more for kind of the lower bandwidth and long range, but there are still lots of products that exist out there for tracking those types of movements that need a network that can support this in potentially underserved and undercovers areas. So the idea that anybody can deploy that coverage, and you're talking about universal tools that are out there that are compatible with the network, can really be a crucial element of how you're enabling that through the connectivity layer.
So for Arcium, I think what's important is that what we've seen in general with blockchains is giving ownership back to the individual, and the same has to happen for data. So data ownership for training data, but also for the data as input data for inference. So confidentiality can be used, confidential compute, to give that ownership back and to offer things like federated learning. The issue that you run into when attempting to do that, of course, is that wrapping confidentiality and encryption around those operations comes with computational overhead. And so what we're looking at is how are we able to overcome those computational hurdles while maintaining confidentiality. So that really is core at what we try to achieve with Arcium, to offer both this trustlessness and high performance. And the way we're going about this is, on the one hand, our parallelized architecture and our computations not having to be executed redundantly by all nodes in our network, but instead it's computational clusters in our network that execute those computations. And those computational clusters can have different sizes and can actually have quite small sizes, simply because those multi-party computations come with the dishonest majority trust assumption, which means that inside of such a computational cluster, there only has to be one party being honest, one party not collaborating with the other parties in that cluster to undermine the confidentiality of that protocol. And so in the context of AI, what we're looking at is parallelization on the data front, the model front, and pipelining, essentially. So there's interesting concepts we're working on. For example, if you think of the training process or the inference process with different layers, we can build a pipeline of those layers and can have different sized clusters, because larger cluster means higher computational overhead for the different phases of the training or inference process, based on how close those layers are to the sensitive data, for example. And I think that's one way we're going about it. And the other way is essentially working on generalizing all of those compute processes as much as possible on the network level. So our network really is super generalized and is able to run those computations while at the same time offering abstractions for AI.
Got it. Super helpful, guys. So I think the common through line across all the networks you've described is crypto as a sort of rails for delivering value at scale and aggregating resources for a bunch of different use cases. I think that's sort of the core of DePIN, that is the structural cost arbitrage that exists across all of the networks that you're building. I think there's like a parallel line of ideals around crypto: openness, transparency, trust minimization, sort of all of the ideological aspects of crypto that could theoretically be applied to AI but aren't. I think people often paint them on different ends of the spectrum in terms of openness, like AI as a massively centralizing force and crypto as the other end of that, like super decentralizing. Why do you guys believe it's important for these systems to be open? Do you guys believe that it's important that crypto primitives can play a role in that? how do you see the role of crypto ideologically informing the way these systems are built, and what role your networks play in making that happen? Maybe Ryan, you can start and we can go from there.
Sure. When I think of crypto and AI, I think the best way to encapsulate the sort of battle that we're fighting is actually a very real court case that's going on right now between OpenAI and the New York Times. And I think that summarizes, and for those who are unaware, the New York Times is alleging OpenAI trained their models, hint, hint, they did, on all of the New York Times archive without paying them. And I think when you think about what the verdict of that is going to be, which we don't know, what you can probably go back and point to is that crypto could have helped to disseminate value to these publishers or other sources of tokens that I'm sure you'll discuss in the answer next, to provide a more transparent understanding of how these models were trained and provide OpenAI a better way to transition the value that they're capturing to the actual people that have created much of the value that one could argue is mostly, the entire source of how these LLMs function. I'll leave it to the experts to describe more than that. But when I think of crypto and AI, I think there's a perfect solution to provide a better, more sustainable way that LLM companies can operate to provide much better value to the data creators. But curious to hear your thoughts.
Yeah, just to add on, I think open source is probably the most important when it comes to AI. But even with open source models now, they don't open source necessarily what data it's trained on. And imagine even if they did, it's so much data. Like, who would actually take the time to go through and really identify what's being used, what's not, what are the weights, and so on? I mean, unless there's a financial motivation there. So that's, I feel like, where the next level of transparency could come in with crypto and blockchain, because as I mentioned before, there's the whole proof of origin. Once you know where that data is coming from, who provided it, who, let's say, vetted it, or who added on to it and whatnot, as long as you have that transparency and traceability, I think that provides another layer of openness. Of course, none of these will be 100% foolproof, right? But I think as a first step, it's best to look in that direction, and I think that's the closest we can get towards having a truly decentralized system where we're able to use open source models and really have full access to all of the data it's used for, whether it's training that open source model or used for fine tuning and so on.
So, when I think about kind of just core like crypto values in terms of like why we're all excited about open permissionless networks, and for us in terms of connectivity of it's all about like level playing fields, and obviously the reversal around net neutrality is like one great step back in the right direction of kind of open networks where speeds are not throttled based on kind of preference and pricing and kind of who's the biggest players pay to play. It becomes these open and fair rules. And I think that's where decentralized wireless plays a very, very meaningful role in terms of being able to, so number one, just that fundamental human right of connectivity, but also when you think about some of these hard to reach places, the idea of user-owned infrastructure, whether that is, are you talking about economically underserved areas that have not seen that type of investment where you can just you've got on the ground empathy that they have connectivity has the best context at a local level. The same way you think of all politics is local. Well, same is effectively true with wireless. Of are you talking about an economically depressed area, or are you just talking about a coffee shop in the middle of Midtown New York that has really crap connectivity where an owner wants to be able to serve their customers better? The idea that should be open and permissionless feels, for everybody in this room, probably feels obvious in the right direction. But I think that kind of agency that you give to communities, to business owners, to individuals is so critical in terms of not just sharing information, but also the right data in the right places. So, when you think about AI and like if you're in, heavy conflict zones where something could be, you want to have censorship resistance in those types of scenarios. And maybe we don't feel that pain as much in the US, but in parts of the world where access to data and access to localized information is absolutely paramount, that's where that connectivity layer has to play a major role. So in terms of like those basic crypto principles to us of that agency and that user-owned infrastructure, that's what really excites us and excites our community.
Yeah, I agree. I think those properties match well, and also on the front of regulation, we've seen that, for example, the European Union's AI Act tries to enforce transparency and accountability onto those LLM firms, and decentralized systems, if done right, are able to create this transparency and decentralized accountability. For us, I think what's important, and that goes into the direction of what Ryan was saying, of the New York Times, data being misused, or now imagine personal user data being misused, your medical record as a patient being misused for exploitation in an AI model. I think those cases can be resolved with decentralizing the technology and making the data usage process both confidential with confidential compute and at the same time transparent and verifiable. And that will add a new dimension to those AI models and might help resolve the fears many organizations and individuals have about their data being used without their data being valued as a valuable resource that belongs to them.
So you're all building sort of foundational infrastructure. Infrastructure is for application developers and applications in general. When you guys think about the demand sides of your networks, do you sort of see this broader vision, these ideals that you were talking about, being led by teams that are explicitly building, decentralized applications, and they're sort of going into it knowing that they want to use distributed infrastructure? Or do you see sort of selling to a standard Web 2 enterprise customer as the route to pursue? And I imagine there's like a good deal of both of these things. Maybe starting with you, Yannik, how do you think about, who to sell to first, and what is the call to action to bring them on?
That's actually a great question. I feel like that we should have a gradual and hybrid approach, and that's what we are doing with Arcium. So I think if your technology is superior to the technology you're replacing in the centralized realm, it should be easy to onboard firms. And our approach is that on a performance and trustlessness front, we can replace centralized systems. But at the same time, it's important that we don't require those customers to buy some tokens and do some on-chain interactions. I think it's important to, in the early stages, especially abstract all of those tasks away, and in a more SaaS-like approach, I guess, offer confidential compute, and the underlying infrastructure then is this decentralized network that just offers the better technology. And centralized aspects in such a interaction between a customer and a network, with some vendors in between, actually isn't problematic, because the network in itself has permissionless access, and data that is being provisioned is encrypted. So there's the user encrypting their data and going through a vendor to move that encrypted data. I think if that helps to onboard companies in this gradual hybrid way, that makes a lot of sense, and that's what we are attempting to do as well.
So, in the Helium world, we're really seeing that from both very, very traditional industry as well as, crypto native. And kind of the beauty of this is it really comes down to just, better connectivity, and the economics make a lot of sense. So, looking at more traditional industry, one of our really great case studies in the network is this fantastic team in Portugal called Green Metrics, and it's very much smart city style solution. So early flood detection and how they kind of rerouting sewage and whatnot. So they went and were solving this problem for the city of Porto, and the fact that this entire community built Internet of Things connectivity layer that was already there for them to be able to deploy a very traditional municipal solution on a community built network where I don't think they had to deploy a single additional gateway. Coverage was so good. So again, just the power of community built networks serving their local area. And we've seen this kind of happen over and over where the network is built out, or to supplement that coverage is so much more cost effective than what private networks traditionally cost. So certainly see the adoption from traditional side, but also, just the symbiosis between crypto native organizations. So, same thing. I don't know how many folks have a demo macaron and you're kind of, providing in-car data. Like a lot of all the location verification for that is sitting on Helium's IoT network. And that just all happens behind the scenes. And again, it just, I think in terms of actually go back to crypto principles. So we talk about the idea of kind of user-owned information. So think about your traditional phone carrier. You are auto-opted in to share your data. On the Helium mobile carrier, it is you have to opt in to share your data. So that's step one of already you're talking about permissioning your data. So crypto principles right there. The second thing is that you're helping to map the network. You're helping to show where there is strong coverage and where there needs to be additional coverage around, where's that foot traffic? Shouldn't you be compensated for that? Isn't this technology here to do exactly that? And that's one of the innovations out of the Helium mobile carrier is this idea of not only is it opt-in for information to share your information, but that you also can be compensated through tokenized incentive model for doing so. So you're helping to build the network not just by providing coverage, but as a user of the network to opt in and be rewarded for that information.
For us, you can sort of see our platform as a two-sided marketplace. So on one side, you have the digital workers, and on the other side, you have the enterprises that need the data solutions. What's interesting is on the digital workers side, we see about 85 to 90% of our users being new to crypto. So they're traditional, maybe crypto curious folks joining because there's an earnings opportunity. And in a lot of these cases, they're coming from emerging countries where traditional Web 2 solutions actually don't recruit these digital workers from there because of the payment issues, because data tagging is inherently a low paying task. And if it's micropayments cross-border, then it's just pretty much impossible. That's why a lot of firms impose withdrawal restrictions, high fees, and all that. So that's something we are seeing where we're opening up these access and opportunity to younger crowds that want to earn extra money. And on the other side of the marketplace, we have enterprises. And all of our current enterprise clients are Web 2. And I think it makes sense because these are more established companies that know exactly what they need in terms of the data. So when we talk to a lot of Web3 companies, they're still in the exploratory mode. That being said, I talked to one of the biggest game companies recently, and they needed a data annotation service. They are building their own in-house content moderation platform. And the guy I was talking to was saying he comes from Google, where they had hundreds, if not thousands, of employees just dedicated to cleaning up data and tagging the data. But at this game company he's at, they don't have the resource. They have a data science team, but there's no in-house resource that can focus on doing all of that data annotation. So all he cared about was if we can deliver the results. It wasn't you guys are Web3, how does that work? He was curious about, how the token incentivized network functions, but at the end of the day, he needed a solution and wanted to know if we can deliver. And I think this is the trend right now. Companies are slowly discovering that they need these kind of solutions. And whether you're Web3, Web2, whatever, if you can provide that solution, I think there's a good, good way to onboard these traditional clients.
Yeah, we only have a few seconds left, but if anyone has investigated their own model training or is familiar with cloud, it's a very competitive market. What I will say is that I do see a large consumer shift toward a desire for crypto principles that we've been discussing here on stage. And app and product folks are reacting as a result of that. So hopefully we'll see a lot more folks that are interested in the way that we all operate our networks and foundations. It's a large consumer shift that I think has been in the works for a while.
Awesome. I think we just started scratching the surface. I'm sure we could be here for another hour, but we're at time. So thank you so much. And yeah.
Thanks, everybody.
Thank you.